So I'll start this question by simplifying that part. And again, I'm given a sub 1 is 3 to the 1. So first thing to do is to just substitute and look for a pattern. And I might add a few more terms here. And then 3 to the 20 to 20. So here the exponent would be 1, 4, because we're multiplying this, 9, 16, and then 400. And I have to, since I have the same base, I'm adding them. And what you'll notice here is that this exponent really is 1 square plus 2 square plus 3 square plus 4 square all the way to 20 square. So the sum of square of the first n natural numbers, it's important to know this result, is equal to n times n plus 1 times 2n plus 1 over 6. So here n is 20, so all I have to do is to replace it with n with 20. This is 41 over 6. This is 3, that's 10, and 7. So I'll leave it in this form, which is 70 times 41. So what we have, this whole thing simplified, is 3 to the power of 70 times 41. So I won't do this multiplication yet. And then the next step is to kind of simplify that one. A sub 21 would be 3 to the 21, 3 to the 22, 3 to the 23, all the way to 3 to the 20 plus m. So again, here we're adding the exponents, 21 plus 22 plus 23, and this is an arithmetic sequence. And the average would be the average of the first and last term. So it would be 21 plus 20 plus m over 2, or 41 plus m over 2. How many terms do I have? Which would be last minus first plus 1. Again, these are all standard expressions from the arithmetic sequence property. So there are m terms. So the sum, again, this is the sum of this exponent here, would be number of terms times the average. So this side becomes 3 to the power of m, 41 plus m over 2. So that's the condition. So this boils down to, since we have the same base, least value of m for which this is true. And again, I'm not going to be trying to solve this. I'll just use the answer choices. And if we plug in m is 58, this would be 99. We're checking this. I think it's easier than doing any further algebra at this point. Divided by 2, so that's 2871. And 70 times 41 is 2870. So that one works. Since we're looking for least value, I don't need to worry about 59. I'll just need to check 57. So 57, this is 98. And this I've already computed it here. Did I make a mistake? 41 times, I don't know why I feel that way. No, I didn't. There's a reason. So 57 times 98 divided by, I'm making some calculation mistakes on the calculator. So I get 2793, which you'll notice is not greater. So, and we don't need to test 56. So the answer is 58. So kind of, I guess, a little bit tedious in terms of setting it up. But if you do it systematically, at this stage, you just have to kind of test the answer choices. And of course, if this was a grid in, you'll have to, there'll be additional work. But, and again, I think you could just try different values as well, just by plugging in numbers. So to summarize, the answer is A.